Space is silent. No sound, no air, no mercy. High above Earth, an astronaut floats alone in the darkness. Below him, the planet looks calm and beautiful. Blue oceans shine under sunlight. White clouds move slowly. From this distance, Earth looks safe, almost peaceful, but the astronaut is not safe. Between life and death, there is only a thin white suit. In space, there is no oxygen to breathe. There is no air pressure to protect the human body. There is no warmth. And there is no forgiveness. Space does not care about bravery, experience, or dreams. The human body was never meant to be here. Without protection, a human can survive only about 15 seconds in open space. In those seconds, oxygen escapes from the blood. The lungs stop working, body fluids begin to boil, the brain loses oxygen, vision fades, consciousness disappears, and then silence forever. Yet, astronauts leave the safety of their spacecraft and work calmly outside. They repair satellites, they connect cables, they build massive structures while floating above Earth at thousands of kilometers per hour. They move slowly and carefully as if space is not trying to kill them. How is this possible? The answer is not courage alone. The answer is technology. This is the story of one of the most important inventions in human history, the NASA spacesuit. At first glance, it looks simple. A white suit, a gold helmet visor, thick gloves, heavy boots, but this is not clothing. This suit is a lifeboat, a shield, a one-person spacecraft. Every tube, every layer, every wire inside the suit exists for one reason only: to keep a human alive in the most dangerous environment known to science. One small failure, one tiny hole, one broken valve, and the story ends immediately. NASA learned this lesson through years of trial and error. In the early days of space exploration, engineers did not fully understand how deadly space truly was. Early spacesuits were stiff, heavy, and uncomfortable. Some astronauts could barely move their arms or hands inside them. During training, test pilots fainted, pressure systems failed, suits locked up at high altitude. Every problem revealed a new danger. In space, mistakes are not forgiven. Slowly, engineers realized the truth. A spacesuit must do many jobs at the same time perfectly. It must provide oxygen to breathe. It must create pressure around the body. It must protect from extreme heat and freezing cold. It must block dangerous radiation from the sun. It must stop tiny space rocks moving faster than bullets. And at the same time, it must allow the astronaut to move, work, and think clearly, all at once. This is what makes the spacesuit one of the most complex machines ever built by humans. Inside the suit, the astronaut is never truly alone. Sensors constantly monitor heart rate, breathing, body temperature, and pressure levels. Every breath is measured. Every second is recorded. If something goes wrong, warning alarms activate instantly. But in space, help is far away. There is no hospital nearby. There is no emergency rescue team waiting. There is no second chance. The suit must work flawlessly. During a spacewalk, astronauts can remain outside the spacecraft for 6 to 8 hours. For all that time, the spacesuit must replace Earth itself. It must replace the sky, the air, the atmosphere. Without it, space would win instantly. Imagine what would happen if the helmet was removed. There would be no explosion, no fire, no dramatic sound, only silence. Air would rush out. Pressure would drop to zero. Oxygen would leave the bloodstream. Vision would blur. Within seconds, the body would shut down. This is why astronauts trust their lives completely to this suit. Before every mission, each spacesuit is tested again and again. Engineers inspect every seal, every joint, every cable, every valve. Nothing is left to chance, because space is not kind. As the astronaut floats above Earth, sunlight hits one side of the suit, making it extremely hot. The other side remains in darkness, freezing cold. Temperatures change faster than anywhere on Earth. The suit adjusts silently. Inside, the astronaut stays alive, calm, focused. This calm is not natural. It is created by engineering. The truth is simple. Without the spacesuit, humans are helpless in space. The suit is the only reason spacewalks are possible. It is the reason satellites can be repaired. It is the reason the International Space Station exists. It is the reason humans can touch the universe beyond Earth. This documentary begins here with the silent test of survival. To understand how a spacesuit works, the story must go deeper. Inside its systems, its layers, its hidden technology, because this suit is not just protection. It is the thin line between life and death. Space looks calm from far away. Stars shine quietly. Planets move slowly. Everything feels peaceful. But this calm is a lie. Space is one of the most violent and deadly places in the universe. For humans, space is instantly hostile. The human body is designed for Earth. Every system inside it depends on Earth's atmosphere, the air pressure, the oxygen, the temperature. Take these away and the body begins to fail faster than most people imagine. The first and biggest problem is air. On Earth, humans breathe oxygen mixed with nitrogen. This air pushes gently on the body with atmospheric pressure. That pressure keeps oxygen inside the blood and allows lungs to work normally. In space, there is nothing, no oxygen, no pressure. When a human is exposed to space, oxygen immediately escapes from the lungs. The blood cannot carry oxygen to the brain. Within seconds, the brain begins to shut down. Loss of consciousness happens very fast, but breathing is not the only danger. The second deadly enemy is pressure loss. The human body is filled with liquids, blood, water, fluids inside cells. These liquids are stable on Earth because of pressure. In space without pressure, these fluids begin to boil not because of heat but because pressure is gone. This process is called ebullition. The skin does not explode but swelling begins. The body expands, tissues are damaged, the tongue can swell, vision becomes blurry, pain is extreme, and all of this happens in seconds. Then comes the third threat, temperature. Space has no temperature like Earth. It is not warm or cold in a normal way. Instead, temperature depends on sunlight. In direct sunlight, temperatures can rise above 120 degrees Celsius. Metal becomes burning hot. In shadow, temperatures can drop below -150 degrees Celsius. There is no atmosphere to balance heat. A human body exposed to this environment would quickly overheat or freeze depending on position. But there is more. Space is filled with radiation. On Earth, the atmosphere and magnetic field protect life from harmful radiation coming from the sun and deep space. In orbit, that protection is mostly gone. Cosmic rays and solar radiation can damage DNA, destroy cells, and increase the risk of cancer. Long exposure can be deadly. Astronauts cannot see this radiation, they cannot feel it, but it is always there, passing through the body silently. Another hidden danger comes from micrometeoroids. These are tiny pieces of rock or metal floating through space. Some are no larger than grains of sand, but they travel at extremely high speeds, faster than bullets. Even a tiny impact can puncture equipment or human skin. In space, even small things can kill. The human body also suffers in zero gravity. Without gravity, muscles begin to weaken. Bones lose strength. Blood moves differently inside the body. Over time, astronauts lose muscle mass and bone density. The heart works differently. The inner ear becomes confused. Balance is lost. Space slowly breaks the human body. This is why humans cannot simply go into space wearing normal clothes or even heavy jackets. Space requires constant life support. This is where the spacesuit becomes essential. NASA engineers realized early on that a spacesuit must recreate Earth around the astronaut. It must provide oxygen like Earth's air. It must create pressure like Earth's atmosphere. It must control temperature like Earth's climate. It must protect from radiation like Earth's magnetic field, all inside a suit. This is not easy. Creating pressure around a human body is especially difficult. Too much pressure and the suit becomes stiff like a balloon. Too little pressure and the body cannot survive. Early spacesuits struggled with this balance. Some suits inflated so much that astronauts could not bend their arms. Simple movements became exhausting. NASA had to redesign everything. Engineers studied human biology. They studied blood, lungs, muscles, and skin. They tested suits in vacuum chambers that simulated space. Mistakes were dangerous. During early tests, astronauts experienced near-fatal situations. Oxygen problems, pressure loss, overheating. Each failure brought new knowledge. Slowly, the design improved. NASA learned that humans do not need full Earth pressure if they breathe pure oxygen. This discovery changed everything. It allowed suits to operate at lower pressure while keeping astronauts alive. This made movement easier, but lower pressure introduced new risks such as decompression sickness. NASA had to create strict procedures. Astronauts must breathe pure oxygen for hours before spacewalks to remove nitrogen from their blood. Every detail matters. Nothing in space is simple. The suit must also manage carbon dioxide. Every time an astronaut breathes out, carbon dioxide builds up inside the helmet. If not removed, it becomes toxic. The suit must clean the air continuously. It must also remove moisture from breathing and sweat. Fog inside the helmet can block vision. Water buildup can be dangerous. All of these systems must work together perfectly. One failure can be fatal. This is why astronauts trust their suits more than anything else in space. When an astronaut steps outside the spacecraft, they leave behind Earth's protection. The spacecraft door closes. Silence surrounds them. From that moment on, the spacesuit becomes their world. It becomes their atmosphere, their climate, their shield. Without it, survival is impossible. Understanding why humans cannot survive in space helps explain why the spacesuit is so complex, heavy, and expensive. It is not over-engineered, it is necessary. In the next part, the story moves deeper inside the spacesuit itself. How does NASA turn a suit into a one-person spaceship? How does it keep an astronaut alive, second by second, in the vacuum of space? That story begins inside the suit, white, smooth, almost simple. But inside that suit, an entire world is working non-stop. When an astronaut steps out of the spacecraft, something important happens. The spacecraft is no longer protecting the astronaut. Earth is millions of kilometers away. The vacuum of space surrounds the human body completely. From that moment on, the spacesuit becomes everything. It becomes the astronaut's spaceship. NASA does not think of a spacesuit as clothing. Engineers call it a life support system shaped like a human body. Inside the suit, machines replace nature. On Earth, the atmosphere does the work. Air pressure keeps the body stable. Oxygen flows naturally. Heat escapes into the air. Carbon dioxide disappears when we breathe out. In space, none of this exists, so the spacesuit must do it all. At the center of this system is the life support unit. This unit sits on the astronaut's back like a backpack. It is called the primary life support system. This backpack is the heart of the suit. It provides oxygen. It removes carbon dioxide. It controls temperature. It manages water and pressure. Without it, the suit is just empty fabric. The oxygen system is always working. Pure oxygen flows from tanks into the helmet. The astronaut breathes normally, but every breath is measured. Sensors monitor how much oxygen is used and how much carbon dioxide is produced. If carbon dioxide builds up, it becomes deadly, so the suit uses special filters to remove it from the air. These filters must work perfectly. Even small failures can cause dizziness, confusion, and loss of consciousness. Time is critical. The suit also controls pressure. Pressure is invisible, but it is life. On Earth, air pushes gently on every part of the body. In space, that pressure is gone. Without pressure, the human body begins to fail. The suit creates artificial pressure around the astronaut, not as strong as Earth's atmosphere, but strong enough to keep blood and oxygen working correctly. This balance is very difficult. If pressure is too high, the suit becomes stiff. Movement becomes painful. Bending arms or fingers becomes nearly impossible. If pressure is too low, the body is in danger. NASA engineers spent years finding the perfect balance. Even today, astronauts describe the suit as fighting against them. Every movement requires effort. Every task takes longer. The suit also manages temperature, one of the biggest dangers in space. In sunlight, the suit heats up quickly. In darkness, it freezes. Inside the suit, the astronaut wears a special cooling garment. It looks like long underwear with thin tubes running across it. Cold water flows through these tubes. This water removes body heat and carries it away from the astronaut's skin. The system adjusts automatically. If the astronaut works hard, more heat is removed. If the astronaut rests, less cooling is needed. This keeps the body temperature stable. The suit also protects from radiation. Space radiation comes from the sun and from deep space. It is invisible and constant. Over time, it damages cells and DNA. The suit cannot block all radiation, but its layers reduce exposure. Every extra layer adds protection. NASA constantly studies radiation levels during spacewalks. The helmet is another critical part. It is not just a piece of glass. The helmet provides a clear view, protection, and communication. The gold visor blocks harmful sunlight and radiation. It also protects the eyes from blinding brightness. Inside the helmet, microphones and speakers allow astronauts to talk with each other and with mission control on Earth. Even in silence, voices travel. If communication is lost, space becomes even more dangerous. The gloves are among the most complex parts of the suit. They must protect the hands while allowing fine movement. Astronauts must hold tools, turn bolts, and connect cables, all while wearing thick, pressurized gloves. This is extremely hard. Astronauts often describe hand pain after spacewalks. Fingernails can bruise, hands can become exhausted, every glove is custom fitted, every finger matters. The suit also includes safety systems. If the main life support system fails, there is a backup. Oxygen reserves allow astronauts to return to the spacecraft safely. Warning alarms alert the astronaut to any danger. Nothing is left without backup. The suit even includes waste management systems. During long spacewalks, astronauts cannot simply stop working. The suit must handle everything. It is truly a self-contained world. Before any mission, astronauts train for years. They practice in giant water pools that simulate zero gravity. Every movement is rehearsed again and again. Because once in space, mistakes cost lives. When an astronaut floats freely above Earth, the suit works silently. Pumps move water, valves open and close. Sensors collect data, the astronaut feels calm. But that calm exists only because the suit is working perfectly. The spacesuit is not just protection. It is the only reason humans can leave their spacecraft. It allows humans to build space stations. It allows repairs that machines cannot do. It allows exploration beyond metal walls. It turns a fragile human into a space explorer. In the next part, the story goes even deeper, inside the most important system of all. How does a spacesuit provide air to breathe and pressure to survive? Because in space, breathing is not natural. It must be engineered. Breathing is something humans never think about. On Earth, it happens naturally. Every second, air enters the lungs. Oxygen moves into the blood. Carbon dioxide leaves the body. The process is automatic and invisible. In space, breathing becomes a problem that must be solved by machines. There is no air in space, no oxygen, no pressure. For an astronaut floating outside a spacecraft, every breath depends on the spacesuit. The moment an astronaut steps into the vacuum of space, the suit begins to work like an artificial atmosphere. Inside the suit, astronauts do not breathe normal air. they breathe pure oxygen. This decision changed the entire design of spacesuits. On Earth, air is about 21% oxygen and 78% nitrogen. That mix works because Earth's pressure keeps oxygen dissolved in the blood. In space, creating full Earth pressure inside a suit would make it too stiff to move. The suit would inflate like a hard balloon. NASA engineers needed another solution. Pure oxygen was the answer. By using pure oxygen, the suit can operate at lower pressure while still delivering enough oxygen to the body. This makes the suit flexible enough for astronauts to move, but pure oxygen brings its own dangers. At high pressure, pure oxygen can cause fires. It can also damage the lungs. NASA learned this through painful lessons, including tragic accidents in early space programs, so pressure levels must be carefully controlled. Inside the spacesuit, pressure is kept at a precise level, just enough to keep the human body alive without making movement impossible. This balance is critical. Too much pressure and astronauts cannot bend their arms or fingers. Simple tasks become impossible. Too little pressure and the body enters a dangerous state. Oxygen cannot move properly through the blood. The risk of serious injury or death increases. The suit constantly monitors pressure. Sensors detect even the smallest changes. If pressure begins to drop, alarms warn the astronaut immediately. In severe cases, astronauts must return to the spacecraft at once. Breathing out creates another problem. Every time an astronaut exhales, carbon dioxide builds up inside the helmet. On Earth, this gas disappears into the air. In space, it has nowhere to go. Carbon dioxide is toxic. If it builds up, it causes headaches, confusion, panic, and loss of consciousness. To solve this, the suit uses special carbon dioxide removal systems. These systems filter the air continuously, removing carbon dioxide and cleaning the oxygen. This process never stops. The suit also manages humidity. Breathing creates moisture. Sweat creates moisture. Without control, water can fog the helmet and block vision. In extreme cases, water can collect inside the helmet and become dangerous. The suit removes excess moisture, keeping the air dry and breathable. Every breath is measured. The suit knows how fast the astronaut is breathing. It knows how hard the astronaut is working. If activity increases, oxygen flow adjusts automatically. The suit reacts in real time. Before a spacewalk, astronauts must prepare their bodies. They spend hours breathing pure oxygen inside the spacecraft. This process removes nitrogen from the blood. Without this step, astronauts could suffer from decompression sickness, also known as the bends. This sickness causes severe pain and can be fatal. Space does not forgive shortcuts. Once outside, the astronaut depends fully on the suit's oxygen system. There is no backup air floating nearby. There is no second chance. The helmet becomes the astronaut's sky. Inside the helmet, air flows gently. Fans move oxygen evenly so that carbon dioxide does not collect near the face. The system is designed to feel as natural as possible, but it is always artificial. The suit also includes emergency oxygen reserves. If the main system fails, the astronaut has limited time to return to safety. Every spacewalk is planned carefully. Time limits are strict. Engineers on Earth monitor oxygen levels constantly. Mission control watches every breath. Breathing in space is not free. It is engineered, monitored, and limited. This is why spacewalks are rare and expensive. The suit does more than just provide air. It controls pressure around every part of the body. The suit must press gently against the skin to keep fluids stable. Without pressure, blood would not flow correctly. Oxygen would not reach the brain. Life would end quickly. The suit becomes a second skin. It presses softly but firmly. Astronauts describe the feeling as wearing a heavy, tight glove around the entire body. Movement requires effort. The suit resists every motion. Over time, astronauts become tired. This is why spacewalks are physically exhausting even though astronauts float weightlessly. The suit is always pushing back. Yet without this pressure, survival is impossible. The suit must also respond to emergencies. If a small leak appears, pressure begins to drop. The system detects it instantly. Alarms sound. Astronauts must act fast. In space, minutes matter. The oxygen and pressure system is the most important part of the spacesuit. Without it, nothing else matters. Tools are useless. Training means nothing. Courage cannot help. Breathing is life, and in space, life depends entirely on engineering. In the next part, the story continues into another deadly challenge. How does a spacesuit protect an astronaut from extreme heat and freezing cold at the same time? Because in space, temperature can kill just as fast as lack of air in space. Temperature is a silent killer. There's no gentle weather, no slow change, no warning. One moment an astronaut is burning in sunlight. The next moment freezing in darkness. On Earth, air protects life. It spreads heat evenly. It cools the body. It keeps temperatures stable. In space, there is no air. Heat has nowhere to go. This makes temperature control one of the hardest problems a spacesuit must solve. When an astronaut floats outside the spacecraft, one side of the body can face the sun. The other side can face deep space. The side facing the sun can heat up to 120 degrees Celsius. The side in shadow can drop to minus 150 degrees Celsius. That is a difference of more than 270 degrees. No human body can survive this. Yet astronauts work calmly for hours. This is possible only because the spacesuit becomes a moving climate system. The secret begins under the suit. Before wearing the outer layers, astronauts put on a special garment. It looks simple like tight underwear, but it is one of the most important parts of the suit. It is called the liquid cooling and ventilation garment. Thin tubes cover the fabric from head to toe. Cold water flows through these tubes continuously. As the astronaut's body produces heat, the water absorbs it. The warm water then moves away from the body and into the suit's cooling system. This process works like an artificial sweat system. On Earth, sweat evaporates and cools the body. In space, sweat cannot evaporate, so technology replaces nature. The cooling system constantly adjusts. If the astronaut works harder, the body produces more heat. The system increases cooling. If the astronaut rests, cooling slows down. The goal is balance. Too much cooling can cause hypothermia. Too little cooling can cause overheating. Both are deadly. The suit must also protect from external heat. Sunlight in space is not filtered by an atmosphere. It is intense and direct. The suit's outer layers reflect much of this heat away. These layers are white for a reason. White reflects sunlight. Dark colors would absorb heat and become dangerously hot. But heat is only half the problem. Cold is just as dangerous. In shadow without sunlight, temperatures drop rapidly. Metal becomes brittle, surfaces freeze. The suit's insulation layers trap body heat. They prevent warmth from escaping into space. These layers work like the walls of a thermos bottle. Inside, the astronaut stays warm. Outside, space remains frozen. This balance must be maintained constantly. If the cooling system fails, body temperature can rise quickly. Astronauts can overheat within minutes. Overheating causes dizziness, confusion, and loss of consciousness. In space, that means death. This is why temperature systems have backups. If one system fails, another takes over. Sensors monitor temperature across the body. If readings become dangerous, alarms warn the astronaut and mission control. Nothing is ignored. The helmet also plays a role. Sunlight can blind astronauts. The helmet visor includes a gold coating that reflects sunlight and reduces heat. Without it, the eyes and face would be exposed to intense radiation and heat. The visor also protects against sudden temperature changes. Even tools become dangerous in space. A metal tool left in sunlight can become burning hot. The same tool in shadow can become freezing cold. Astronauts must be careful what they touch. The gloves protect hands from extreme temperatures, but even then, astronauts feel discomfort. Temperature is always present. The suit must manage internal heat as well. Astronauts work hard during spacewalks. They pull cables, turn bolts, hold heavy tools. Even in zero gravity, work is exhausting. The human body produces heat during physical effort. Without proper cooling, that heat builds up. The liquid cooling system removes this heat continuously. The warmed water travels to a heat exchanger. There, heat is released into space through special systems. This process keeps the body stable. Everything happens silently. The astronaut does not hear pumps or fans clearly. The system works in the background. This silence hides complexity. Temperature control is one of the main reasons spacesuits are heavy and expensive. Each layer adds protection. Each system adds safety. NASA engineers test these systems under extreme conditions. Vacuum chambers simulate space. Temperatures are pushed to dangerous limits. If a system fails on Earth, it is redesigned. Because in space, failure kills. The history of space exploration includes many close calls. Astronauts have reported feeling too hot or too cold during spacewalks. Engineers studied every report carefully. Small adjustments save future lives. The suit continues to evolve. Future spacesuits will have better temperature control. They will adapt faster. They will protect astronauts on the Moon and Mars. But the challenge remains the same. Space is not friendly. It tries to freeze you. It tries to burn you. The spacesuit stands in between. It fights fire and ice at the same time. Without temperature control, oxygen would not matter. Pressure would not matter. The body would fail anyway. This is why temperature control is not optional. It is survival. In the next part, the danger becomes even more violent. Tiny space rocks, invisible bullets, radiation from deep space. How does a spacesuit protect an astronaut from impacts and radiation? Because in space, danger does not always come slowly. Sometimes it comes at thousands of kilometers per hour. Space is not empty. It looks empty. It feels empty, but it is filled with invisible danger. While an astronaut floats silently above Earth, thousands of tiny objects move around at incredible speed. Pieces of rock, metal fragments, dust from old satellites. They are called micrometeoroids and space debris. Some are as small as grains of sand, but size does not matter in space. Speed does. These tiny objects travel faster than bullets, sometimes over 28,000 kilometers per hour. At that speed, even a small particle can be deadly. A direct hit on an unprotected human body would be fatal. This is why the spacesuit must act like armor, but it cannot be heavy metal armor. Astronauts still need to move. So NASA engineers designed a different kind of protection, flexible, layered, and smart. The outer shell of a spacesuit is made of multiple layers. Each layer has a specific job. The outermost layer is tough and resistant. It is designed to take the first impact. If a micrometeoroid hits, this layer absorbs part of the energy. Below it, more layers slow the object down. Instead of stopping the impact all at once, the layers spread the force. This reduces damage. Some layers are designed to tear in a controlled way. This tearing absorbs energy just like crumple zones in cars. If one layer fails, another layer is still there. Redundancy saves lives, but micrometeoroids are not the only threat. Space is also filled with radiation. Radiation is silent, invisible, constant. On Earth, humans are protected by the atmosphere and magnetic field. In space, that shield is mostly gone. Radiation comes from many sources. The sun sends out solar radiation. Sometimes it releases powerful solar storms. These storms can send dangerous energy across space. Beyond the sun, deep space sends cosmic rays, high-energy particles moving near the speed of light. These particles pass through the human body. They damage DNA. They harm cells. They increase the risk of cancer. Astronauts cannot see or feel this radiation, but it is always there. The spacesuit cannot block all radiation. That would require thick metal shielding, which would be too heavy. Instead, the suit reduces exposure. Special materials slow down radiation particles. Multiple layers increase protection. NASA carefully plans spacewalks to avoid high radiation periods. If solar activity increases, spacewalks are delayed or canceled. Sometimes astronauts must return quickly to safety. Time matters. Radiation exposure is carefully measured. Sensors on the suit track radiation levels. Mission Control monitors these readings constantly. Every spacewalk adds to an astronaut's lifetime radiation exposure. This is why astronauts cannot spend unlimited time in space. The suit also protects against ultraviolet light. Sunlight in space is extremely intense. Without atmospheric filtering, ultraviolet radiation can damage skin and eyes very quickly. The helmet visor blocks most of this radiation. The gold coating on the visor is not for style. It reflects harmful rays and reduces glare. Without it, astronauts could go blind. Even heat protection plays a role in radiation defense. Some radiation carries heat energy. Reflective layers help reduce this effect. The suit must handle many dangers at once. Impact, radiation, heat, cold, all without failing. Space debris is becoming a bigger problem every year. Old satellites, broken parts, lost tools. Human activity has filled orbit with dangerous objects. NASA tracks thousands of large pieces of debris. Smaller pieces are harder to track. Astronauts rely on the suit's protection. During spacewalks, Mission Control watches debris paths closely. If a dangerous object is predicted to pass nearby, astronauts may be ordered to return immediately. There is no hero moment, only survival. The suit must also protect against sharp edges. Spacecraft surfaces can become brittle in extreme temperatures. Metal cracks, paint flakes off. Astronauts move carefully to avoid tearing the suit. A small tear can cause slow air leaks. Slow leaks are dangerous. Pressure drops quietly. This is why suits are designed with strong inner layers that hold pressure even if the outer layer is damaged. Engineers assume damage will happen. They prepare for it. The history of spaceflight includes many close calls, tiny impacts, near misses, alarms sounding during spacewalks. Every incident leads to better design. NASA studies everything because space never stops being dangerous. For the astronaut inside the suit, most of this danger is invisible. The suit hides it. The astronaut feels protected. But protection is never complete. That is why spacewalks are carefully limited in time. Every extra minute increases risk. The suit is strong but not invincible. It is a barrier between fragile human life and a violent universe. Without it, humans would last seconds. With it, humans can explore. In the next part, the danger becomes personal. Movement, pain, physical limits. How does a human body work inside a stiff, pressurized suit? And how far can the body be pushed before it breaks? That story continues next from the outside. A spacewalk looks peaceful. An astronaut floats slowly. Movements are smooth. Everything feels calm and controlled. But inside the spacesuit, the reality is very different. A spacesuit is not soft. It is not flexible like clothing on Earth. It is a pressurized machine fighting every movement. The moment the suit is sealed and filled with oxygen, it becomes stiff. The fabric wants to expand. Every joint resists bending. To move an arm, the astronaut must fight the pressure. To close a hand, the astronaut must fight the glove. Every motion requires strength. Even simple actions become hard work. Astronauts often describe spacewalks as one of the most physically demanding activities they have ever experienced. There is no gravity, but there is constant resistance. The gloves are the hardest part. Hands are extremely sensitive. They are used for fine movements. In space, hands must work inside thick pressurized gloves. These gloves protect from vacuum, temperature, and debris, but they take a heavy toll. To bend a finger, astronauts must push against internal pressure. Over hours, this causes pain. Fingernails can bruise, skin can become damaged. After long spacewalks, astronauts often lose feeling in their fingers. Some experience nerve pain. Every glove is custom made. NASA measures each astronaut's hands carefully. Small differences matter. A poorly fitted glove can cause serious injury. Even with perfect fitting, pain is unavoidable. The suit also limits range of motion. Bending at the waist is difficult, turning the head is limited, looking down requires moving the entire upper body. Astronauts must plan movements carefully. Wasting energy is dangerous. A spacewalk can last 6 to 8 hours. The suit has limited oxygen and cooling capacity. Fatigue is a serious risk. Inside the suit, sweat builds up. Muscles work constantly. Heart rate increases. The cooling system helps, but exhaustion still happens. Astronauts train for years to prepare. They spend hundreds of hours underwater in giant pools. The water simulates weightlessness. Every task is practiced again and again, because in space there is no room for learning. The suit also affects balance and orientation. Without gravity, the body's sense of up and down disappears. The inner ear becomes confused. Astronauts rely on visual reference points. Disorientation can cause mistakes. The suit's helmet limits peripheral vision. Astronauts must turn their entire body to see around them. Simple awareness becomes effort. The suit also creates pressure points, shoulders, hips, knees. Over time, these pressure points can cause pain and bruising. Some astronauts compare spacewalks to wearing a stiff armor for hours while doing heavy labor. Despite all this, astronauts remain calm. They move slowly, they breathe carefully, they focus on each task. This discipline is critical. A mistake in space is not just an error, it can be fatal. The suit includes restraints to help movement. Astronauts use handrails, foot restraints, and tethers to stay stable. Without them, even small pushes can send an astronaut drifting away. The suit has no propulsion of its own in most missions. Control depends on careful movement. The suit also includes a safety tether. This thin line connects the astronaut to the spacecraft. It is the last line of safety. If it fails, the astronaut could drift into space forever. This has happened before. History remembers accidents and close calls. Each incident changes how astronauts train and how suits are designed. The suit also limits communication through body language. Facial expressions are hidden behind the visor. Astronauts rely on voice alone. Clear communication is essential. Fatigue can affect judgment. This is why mission control constantly monitors astronauts' physical condition. Heart rate, breathing, oxygen use. If signs of extreme fatigue appear, the spacewalk may be ended early. Human limits are real. No technology can remove them completely. The spacesuit does not make astronauts superhuman. It only allows them to survive. Inside the suit, time feels different. Minutes pass slowly. Every movement is planned. Every task takes longer than expected. Yet astronauts continue. They push through pain and exhaustion, not because they are fearless, but because they are trained and because they trust the suit. The suit protects them from space, but it also tests them. It reveals human limits. In the next and final part, the story moves forward. How will spacesuits change in the future? How will humans walk on the moon again and one day on Mars? What will stand between life and death in those distant worlds? That story comes next. The astronaut slowly moves back toward the spacecraft. Earth fills the background, blue, bright, alive. After hours in the deadly vacuum of space, the hatch opens. The astronaut enters, the door closes, air returns. For the first time in hours, the spacesuit is no longer the only thing keeping a human alive. The spacewalk is over, but the story of spacesuits is far from finished. In fact, it is just beginning. The spacesuits used today are the result of decades of learning. Every mission, every mistake, every close call. They allowed humans to walk on the moon. They allowed the building of the International Space Station. They allowed humans to survive where survival should be impossible, but the future demands more. NASA and other space agencies are now preparing for the next chapter of human exploration. Humans are going back to the moon. And this time, they are not just visiting, they are planning to stay. The moon is a very different world. Its gravity is weaker than Earth's. Its surface is covered in sharp dust. Temperatures change dramatically between day and night. Old Apollo spacesuits were not designed for long-term use. Astronauts struggled to walk, dust damaged joints, movement was limited. Future missions require new suits. These suits must allow astronauts to walk, bend, climb, and work for long periods on the moon's surface. NASA next-generation suits are designed to be more flexible. They allow movement at the waist. They allow better leg motion. They allow astronauts to kneel and stand more naturally. These suits are built for exploration, not just survival, but the moon is only the beginning. The real challenge is Mars. Mars is farther away, colder, more dangerous. A mission to Mars could take years. Astronauts would face long-term radiation exposure, extreme isolation, Limited rescue options. On Mars, the atmosphere is thin. Oxygen is almost non-existent. Temperatures are freezing. Spacesuits for Mars must be tougher, lighter, and smarter. They must protect astronauts from radiation for much longer periods. They must handle dust storms and rough terrain. Engineers are working on suits that astronauts can step into from the back, directly from their habitat. This design reduces dust entering living spaces. Technology is changing everything. Future suits may include smart materials that adjust automatically, materials that become stiff when hit and flexible when moving, materials that repair small tears on their own. Sensors will become more advanced. Suits will monitor not only heart rate and oxygen, but stress, fatigue, and mental focus. Artificial intelligence may assist astronauts. The suit could warn when the body is reaching dangerous limits. It could suggest rest. It could adjust systems automatically to reduce strain. The suit will become a partner, not just a tool. But no matter how advanced technology becomes, one truth remains the same. The human body is fragile. Space does not care about progress. It does not care about dreams. It remains silent, cold, and unforgiving. The spacesuit will always be the thin line between life and death. Every future step on another world will depend on it. Every footprint on the moon, every step on Mars, every human moment beyond Earth, all will be protected by layers of fabric, metal, and engineering. When future astronauts stand on the moon again, Earth will shine in the sky, small, blue, distant. They will look back at the planet where life began, and between them and the endless universe there will be a spacesuit, not just a suit, a miracle of science, a shield against the impossible, a symbol of human courage and intelligence. The spacesuit is proof that humans adapt, that humans learn, that humans refuse to stay grounded. From the first dangerous experiments to the most advanced designs, the spacesuit has evolved with us. It has saved lives, it has enabled exploration, it has turned dreams into reality. As long as humans reach for the stars, the spacesuit will be there. Quiet, reliable, essential. Because space will always test us, and the spacesuit is our answer. End of documentary.